afternoon, everybody. I hope you guys are doing well. Today we're going to do a short little podcast of getting the molecular formula from the empirical formula. If you recall in homework 7, you were doing the empirical formula, which is the lowest whole number ratio, and we're going to see if it's the same as the molecular formula or not by comparing it to a given molar mass that they're going to give you to determine if they are the same. So we're going to take a look at our practice problem on page 207. And if you look on page 207, you guys are in the yellow box, and it says that a compound used as an additive for gasoline to help prevent engine knock shows the following percent composition. So you can see the amount of chlorine, carbon, and hydrogen there. Keep in mind we're going to assume a 100-gram sample again, so we can just use those as grams. The molar mass is known to be 98.96, and determine the empirical formula and the molecular formula. So that molar mass that's given, we can worry about that at the very end. Right now we're just going to work with the percentages. So just like we did in homework 7, we're going to do the same thing. We're going to assume a 100-gram sample. Oh, there's the bell. So we have chlorine, and it tells us 71.65%, so we're going to say it's that many grams, divided by the molar mass of chlorine, and that's 2.02 moles. So I'm not doing anything new. I'm just taking the percentages that they gave us, and I am converting them to the number of moles. The molar mass for carbon is 12.0 grams per mole, and that is also going to be 2.2 moles. I like when they give us these nice, easy numbers. And then it's 4.07 grams of hydrogen. We know the molar mass of hydrogen is 1, so we're actually going to get 4.07 moles. Now, if you recall, we need to divide by the lowest number of moles. And so in this case, it's going to be 2.02, which gives us 1. Divide by 2.02, which gives us 1 again. And divide by 2.02, which gives us 2. So I can say that my empirical formula is equal to 1 chlorine, 1 carbon, and 2 hydrogen. Okay, so the first thing that you need to do then to go to the next step is I need to find the molar mass of the empirical formula. So you would add up 1 chlorine, 1 carbon, 2 hydrogen, and you would find that the molar mass, so I have 1 chlorine plus 1 carbon plus 2 hydrogens, and this molar mass is going to be 49.5 grams per mole. You can verify that if you'd like in your calculator by looking at your periodic chart. Okay, so now what I need to do is I need to go up and I apply the ratio. So molar mass of the compound, that was given in the problem. Molar mass of the empirical formula, I just figured out. So we're going to see if the empirical and the molecular formula are exactly the same. And you're going to see that they aren't. So the ratio, first we'll use the molar mass that's given in the problem, 98.96 grams per mole. And then the empirical molar mass that we just found, which is hidden there, was what? 49.5 grams per mole. And that's going to be equal to 2, approximately equal to 2. So the empirical formula and the molecular formula are not the same. So my empirical formula was ClCH2. I need to multiply that by 2. So I'm going to get Cl2, 2 carbon, and 4 hydrogen, and this is going to equal my molecular formula. Okay, so that is it. Now, if you guys go ahead and look at homework 8, you're going to see that, let's see, oh shoot, on homework 8, I guess I don't have it on here, I thought I did. On homework 8, questions 1, 2, and 3 are exactly what I just showed you. So go ahead and try 1, 2, and 3. I'm going to record another podcast that's going to show you how to do question number 4 through 7, 4, 5, 6, and 7. So turn this one off, try those first 3, and then if you have time, listen to the next podcast that's going to show you combustion reactions. I hope you guys have a wonderful night, and I will see you soon in class.